Hi everyone, my name is Peter. Welcome to this YouTube tutorial. In this section, we are going to be looking at Organic Chemistry 1. And if you've taken Genochemistry 1 and Genochemistry 2, Organic Chemistry 1 is totally a different world from the chemistry that you've been doing. So everything here is new except for this beginning chapter. It's just a review of the previous work that we did in Genochemistry 1 and 2 about the atom and electrons. But this organic chemistry, first of all, it needs dedication, a lot of memory work, and also a lot of reading. So get a bit prepared, but I'm here to make it very easy for you. So let us jump into our objectives today. The first one, we have the definition of organic chemistry, the structure of an atom, quantum mechanics, and then lastly, if time permits, we shall look at the covalent bonding. So therefore, let me begin with the definition of organic chemistry. So we say this word organic in a lot of many things. Like today here in the US, we talk of organic foods. We talk of when you go to the to do groceries, and most people prefer organic food. But the word organic basically means that this compound or this component or this item has a lot of carbon in it, and we know that carbon is one of the basic units elements of life. So most of the compounds that we have in organic chemistry contain carbon. So organic chemistry is simply the study of carbon and its compounds. So we have carbon as the major compound, and hydrogen, nitrogen, oxygen, phosphorus, sulfur. Basically, these are the most important elements that we deal with in organic chemistry, though at some instances we shall have more of inorganic chemistry with it, but mostly the biggest part is organic chemistry. So basically, organic chemistry is the study of carbon and its compounds, and in our next second chapter, objective, it's the structure of an atom. I will refer you that to one of my YouTube videos that I did earlier about the structure of an atom. So we shall skip this for now. Check out my video, and you come back and continue with the third objective, which is the quantum mechanics. So under quantum mechanics, I'm going to go through just a little bit of this because this is also a chapter on its own. And so to begin with quantum mechanics, very long time ago, before after the discovery of electrons and protons and neutrons, so scientists used to think that now these electrons how are they behaving in an atom? How are they structured? Where do we find them? So they used to think that electrons in an atom are just rotating around the atom, just like the way the planets rotate around the sun. So that's what scientists used to think, and until one of the scientists called Lewis, who tried to explain that actually what happens that these electrons have energy levels. So, and these energy levels, they move in energy levels. So electrons that are near the nucleus have a specific type of energy than those that are very far away from the nucleus. So from that, they obtained, he used Albert Einstein's equation and Planck's equation to bring up the properties of an electron. He showed that electrons sometimes behave as particles and also in most cases behave as waves. So that was basically the theory in quantum mechanics, and the main goal in quantum mechanics is to find the exact location of an electron. That's what they were trying to do, and they came up with a number of sophisticated calculations that we use in form of letters or numbers that you will see as we go on. And from that, chemists use that idea to explain the following objectives that I laid here. So the first one was atomic orbitals. So they classified atomic orbitals to be we have an s orbital, a p orbital, a d orbital, and an f orbital. And the maximum electrons that we have in an s are 2. In the p orbital we have 6, in the d we have 10, and the f we have 14. So this is how they classified the orbitals and the maximum electrons held in them is that. And then on the third node we shall look at the degenerative orbitals. So to take a good example about the p orbital, so the p orbital was further classified into px, py, and pz. So this just means that these electrons are either found on the x-axis, y-axis, or on the z-axis. So if this is my axis, this is my x, and this is my y, then my z-axis will be something like this. So these electrons are either found on the z, or on the x, or on the y. So basically that's how it is. So these electrons, they're just, remember I said quantum mechanics is all about finding the exact location of electrons. So in the p orbital they say they are either on the x, or on the y, or on the z, and each of these holds 2 electrons, so having a maximum of 6. So these 6 electrons in the p orbital are called degenerative orbitals because they have the same energy level. They are on the same level, they have the same energy. Then to drop down to ground state electronic configuration, this is basically telling us the electronic configuration of an element in its stable state. For example, if I may choose carbon. Carbon is atomic number 6. So carbon has an electronic configuration of 1s2, 2s2, then 2p2. So now this is the ground state electronic configuration of carbon when it's in ground state, when it's stable at a low energy. So when an element is said to be stable in chemistry or organic chemistry, it means that it has a low energy. So stability does not mean you have high energy, but it means you have low energy. So at this state, carbon has a low energy. But in an excited state is when one of these electrons from the low energy gets excited or moves from the low energy level to higher energy levels. Like for example, if this one is 2, so if this is 1s, then 2s, and then this is 2p. So I had 2 electrons here spinning in opposite direction, and 2 here. So this is the electronic configuration of carbon. So when one of these electrons gets excited and moves to this orbital, so the final structure will be like this. So that's what we call being in an excited state. And carbon exists in this form, and this process is called hybridization. So we shall talk of hybridization in this organic chemistry. It's a language in chemistry, so you have to be knowing. We shall do more chapters about hybridization in the time to come. So for today, this was just a basic introduction of organic chemistry. In the next chapter, we shall look at we shall continue with covalent bonding. So thank you very much for tuning in today. Bye for now.